For this one, we're looking for the approximate enthalpy of the reaction. And what we're going to need to do here is follow the instructions. It says we have 6 C atoms joined together in a straight line. So let's do that first. And it says here we need as many hydrogens connected so that each C atom has 4 bonds on it. So that means that this C will need 3 hydrogens. So it has 1, 2, 3, 4 bonds on it. This one needs another 2 hydrogens. This one needs 2. This one needs 2. And this one needs 2. And this one needs 3. Alright, so that's the carbon structure there. And it's added to as many O2 atoms. So I'm just going to do that, O2 atoms. And O is double bonded to O. That's an O atom. It's double bonded to another O atom. As would be required to give CO2, which is like this, C double bonded to 2 oxygen atoms, and water. Now this is not balanced. So what I'll do first is I will balance this over here, and I'll just do this as molecular formula. It's a little bit easier. So C6H14, you can take my word for it, there's 14 hydrogens here, plus O2 gives CO2 plus H2O. Now to balance this, I'll put a 6 in front of the carbon. I'll put a 7 in front of the water here. Now if I do that, you'll see that this will be 6 times 2 is 12. 7 times 1 is 19. So that'll be 19 over 2 O2 atoms. So then when I fix this, it'll be 2 C6H14 plus 19 O2, and then that gives 12 CO2 and 14 H2O. So that should be balanced now. So what I can do is for each of these I can figure out how many CH and CC and OO double bonds and C double bond O's and OH bonds we have, and then I can apply that down here so that we can figure out the actual enthalpy. But let's look at this first. We'll look at C6H14 first. And if you look at C6H14 and we count them, we've got 1, 2, 3, 4, 5. That would be 5 CC bonds there. To join 6 carbons together. And then if you count around here, you'll see there's 14 CH bonds. Now over here we're going to have, and that's just for one of them. So over here if we've got 2 of them here, then that would be a total of 10 CC bonds and a total of 28 CH bonds. We've got 19 O double bond O's. We've got 12 CO2s, but each of these has 2 C double bond O's, so that'll be 24 in total C double bond O's. And each of these waters, so you've got 2 here, each of these waters has 2 OH bonds, so that would be a total of 28 OH bonds. Now the formula that we're going to use here for bond enthalpy, or energy from bond enthalpy, is will be down to delta H is equal to the sum of the bond energies of the reactants minus the sum of the bond energies of the products. Notice it's reactants minus products when we're doing this from the bond energies. It's the opposite way around when we're doing it from heats of formation. So it's all of these added together on the reactant side. So it would be 10 times C double bond C plus 28 times CH plus 19 times OO double bond. I'll put that in square brackets, and then I will subtract 24 by C double bond O, and 28, and that would be added to 28 by O single bond H. Now we have the figures up here for what they are. We've got C single bond C, that's 347. So it'll be 10 times 347. The CH here is 414. The OO double bond is 498. The C double bond O is 736. And the OH is 464. So all we would have to do then is just go ahead and add all these together, subtract all of these. See, add all these together. Let me just put a little thing underneath here. Add all those together. So it'd be 10 times 347, 28 times 414, 19 times 498, and then subtract 24 times 736 and added to 28 times 464. I'll leave you to do the math on that, but that's the basic method that you'll use.